In the previous lecture, we have discussed the concept of Laplace transform, ROC, property of ROC, and the Laplace transform of some basic signal. Today, we are going to discuss some problem based on this Laplace transform. Okay, our first problem is to determine the Laplace transform of e to the power minus 2t ut minus e to the power minus t ut. Okay, then our goal is to find the Laplace transform of this signal and their ROC. Okay, as we know that this follow the linearity property, and we may find the individual Laplace transform and then combine it to find the Laplace transform overall, and their ROC is also combined. Okay, the first property, or the first previously we have discussed about the Laplace transform of e to the power minus at, and we know that the Laplace transform of e to the power minus at is 1 upon s plus a, because Laplace transform of ut is nothing but 1 upon s and sigma greater than 0. And we know that the multiplication property e to the power at, when multiplied with any signal, let's suppose ut, then in Laplace transform only s become s plus a, or s is replaced with s plus a, and and same ROC, the sigma plus a greater than 0, therefore the sigma is equal to minus a. We apply this property here, and finally we know that the Laplace transform of e to the power minus at ut is nothing but the s plus a, and their ROC become sigma greater than minus a. Okay, as this is something like that, then the Laplace transform of e to the power minus 2t ut is nothing but 1 upon s plus 2, and their ROC becomes sigma greater than minus 1 upon minus 2. And the signal e to the power minus t is nothing but right-handed signal, and it will look like this. Therefore, their ROC is also right-handed. From this ROC, it is minus 2. Let's suppose this is the pole minus 2, and then ROC is also right-sided. Okay. Similar for the next e to the power minus 3t, we also get this is 1 upon s plus 3, and their ROC becomes sigma is greater than minus 3. This is same, both the signal same, but both the signal look like same, and their ROC is different. Actually, the ROC of first signal is sigma is greater than minus 2, and ROC is second signal sigma is minus 3 greater than minus 3. Then in last we combine this signal, and ROC is also combined with the same respect. Okay, and when we consider individually, then ROC of this signal actually it is greater than minus 2, and it is also a right-sided. And ROC of this signal, it similarly from minus 3, it is also right-sided, because both signal is right-sided signal. When we combine this, then minus 2 here and minus 3 here. If we consider minus 3, then it also then the pole minus 2 is also in between the ROC, and we know the property of ROC that the ROC must not contain any pole. Therefore, the overall ROC is equal to minus 2. Therefore, the pole minus 3 is not in between the ROC. Or in short term, we know that if the signal having both right-sided signal, then we consider only rightmost pole. Then rightmost pole is -2, and then overall ROC is -2. Okay, the overall ROC is -2. Therefore, when we combine this, the Laplace transform of this signal become 1 upon s square plus 5s plus 6, and overall ROC is, sorry, it is mistakenly printed here, -2. Sigma is greater than -2. Okay, move to the next. Our next signal is determine the Laplace transform of minus e to the power minus 2t u minus t and e to the power minus 3t minus t. Actually, both signal is now a left-sided signal, and when we plot this signal, it look like this. Okay, when we plot this signal, it look like this, and similarly when we plot this signal, it look like both signal is neither energy nor power. Both the signal neither energy not power. The Fourier transform of the signal not possible, but the Laplace transform somehow converge because of the ROC and because of the value of sigma. Okay, and we know the property, we know that we have already solved this type of question, because if the Laplace transform of e to the power minus at minus, and both minus, here is also minus and this is also minus, then it is similar to e to the power minus at ut, and Laplace transform of both the signal is same. Only difference is ROC. In this signal, the ROC is greater than the minus a, but for this it is less than the minus a. Okay, this, if we put minus here, then 1 minus replacing here, and if we put again -1 minus here, then it become positive. Okay, you remember this point. Okay, therefore this signal, the Laplace transform become 1 upon s plus a, and ROC become left-sided because the both signal is left-sided. Therefore the Laplace transform of e to the power minus 2t u minus t, then their Laplace transform is e to the 1 upon s plus 2, and ROC become sigma is less than -2. Similar for this case, Laplace transform of equal to 1 upon s plus 3, and sigma become -3. Okay, when we combine this, the ROC of this signal is sigma less than -2. From the, okay, we'll draw next. When we combine this signal, and the ROC of this signal is nothing but it is left-sided of -2, and ROC of this signal is nothing but -3. As both signal is left-sided, therefore from the property of ROC, we know that the ROC does not contain any pole, and when we combine this, -2 in this side and -3 this side, and from -2 it is not possible to draw this ROC because it contains -3 inside this ROC. Therefore the only possible is to take leftmost value of sigma. Therefore the overall combination become ROC become sigma is less than -3. Then our value is this. I hope you don't face any problem because it follows the property of ROC, and you also clear the property of ROC. Then our next question is, in the first question we see the case of, in our first question we see the case of both signal is right-sided. Okay, and in our second question we see the case where both signal is left-sided, And now our third problem is based on the question where both signal is both one signal is left sided and one signal is right sided. Okay, then our question is to find the Laplace transform of e to the power minus a mod of t, and we know the property of mod of t, and the mod of t value equal to minus t, as we discussed here, minus t when 1 minute. The e to the mod of t value equal to minus t when the t is less than 0, and it is equal to positive t when t is greater than equal to 0. Therefore, this e to the power minus a mod of t become e to the power minus at for t is less than 0, and e to the power minus at when t is greater than 0. Okay, then when we break this signal into two parts, then first of this signal, because it is a left sided signal and t is less than 0, therefore it is nothing but u minus t, and as it is a right sided signal, then it is nothing but u positive t. Okay, then this signal e to the power at minus t become left sided signal, and e to the power minus at ut become right sided signal. Okay, now find the property of individual of the signal. Then we know that e to the power minus at ut become 1 upon s plus a, and if we combine both minus here and minus magnitude, then the Laplace transform is same, but the ROC here is greater than 0, greater than minus a, and here ROC is less than minus a. Okay, then we find the first Laplace transform. Then we find first Laplace transform of first signal, which is nothing but e to the power at u minus t. Then it become minus a. If we positive here, then here minus become, it is minus 1 upon s minus a, and the ROC, as the signal is left sided, therefore the ROC is also left sided, then sigma is less than a, because the value of a s is equal to a. Okay, then this signal is Laplace transform of this, and their ROC become sigma less than a. Okay, next signal is right sided signal, and its value become s plus a, as this is explained here, and their ROC is sigma is greater than minus a. When we combine this signal, when we plot the x value of x, when we plot the signal xt, then it is a both sided signal. This is left sided and this is right signal, and we know that the as we know from the property of ROC, the left sided signal having the ROC left sided, and the right sided signal having the ROC is right sided. Okay, and we from right sided, if we plot this for this signal, the ROC must be greater than minus a. Then when we plot this greater than minus a, when we plot this two pole in s plane, one at this position minus a, and one at the position where a is, sigma is equal to a, and from this signal it shows that the sigma should be greater than minus a, therefore this is greater than. Okay, and for the second signal, sigma should be less than a, then this is, and this common ROC from minus a to a, it is a common ROC of the both combination of this signal. Okay, if this common is not possible, then if the common of the two signal is not possible, then ROC is not possible. Therefore, for this signal, for that type of signal, the Laplace transform cannot be defined. Okay, when we combine this, the Laplace transform of this signal become minus 2a divided by s square minus a, and ROC become in between minus a to a. Therefore, the sigma should be greater than minus a and less than a, greater than minus a and less than a. This is our solution. Now, in the same topic, we have also discussed the left-sided signal, right-sided signal, and two-sided signal, and now again the two-sided signal, but having no common ROC. Okay, our next signal is e to the power minus at u minus t and e to the power minus u to the power at ut. Okay, and when we find this Laplace transform of this signal, then this signal produce Laplace transform minus 1 upon s plus a, and as the signal is left-sided, then ROC is also left-sided, sigma is less than a, and similarly for this signal, it is a right-sided signal, then ROC should be a greater than sigma greater than a. Okay, when we plot this signal xt, here we know that this signal is both-sided signal, and when we integrate this become infinite, and Fourier transform does not converge. But Laplace transform possible if they have common ROC. But when we plot it for the first signal, sigma should less than minus a, as it is a left-sided, and minus a at this position, and their ROC at the left side. Okay, and for this signal, sigma must have greater than a pole at this position and a at this position, and the sigma is also greater than 0, as there is no any common ROC. Therefore, Laplace transform does not exist for this type of signal. Therefore, we conclude here that if there is no common ROC of any signal, then their Laplace transform does not possible. Okay. Let's move to the next question. It is a similar exponential type, and it is most important as paper in the question paper they ask for the Laplace transform of sin omega t and cos omega t. Okay, and we solve this question parallelly for the sin and cos, as it is easy, as we have solved earlier the question based on e to the power sigma multiply with the ut or something like that. Okay, and the first question is find the Laplace transform sigma omega t ut, and the second question is cos omega t ut. Okay, when we break it into exponential part, then sin omega t become e to the power minus e to the power j omega t minus e to the power minus j omega t divided by 2j. In same case, in the cos omega t, it is also divided into break into exponential part, and it become e to the power j omega t and e to the power minus j omega t positive part, and add them and then divide by 2, and ut multiply to the overall signal. Therefore, the both signal multiply with ut. Okay, as both ut is right-sided, therefore their ROC also becomes right-sided. Okay, we know the property of exponential. We know the property of multiplication of exponential signal. Okay, it is same like that. When in the previous case, it is multiply with the e to the power j omega t multiply with the ut. As it is positive, then their Laplace transform it is negative. Therefore, it will become s minus j omega t. Same case here, it become s plus j omega t. Similar. Okay, Laplace transform of j omega t is nothing but 1 upon s minus j omega t. Laplace transform minus j omega t become s plus j omega t. Same case here. Similarly, and for the both the signal having right-sided, and there is no real part, and we know that the ROC is nothing but the real term of s is greater than 0, and in this signal both the signal j omega t is imaginary term, therefore no real term present in this signal. Therefore the ROC still have sigma greater than 0. In previous case, s minus a, where a is real term, therefore the sigma is greater than the real term. Okay, therefore the both the signal having same imaginary part in the same cos for the cos imaginary part, therefore the sigma must greater than the 0 because they have no any real term, they all are the imaginary term. And when we combine, then because both the signal having right sided and greater than 0, when we combine then and common ROC become sigma is greater than 0 and sigma is greater than 0. Okay, we combine all the signal, then we get omega square s square omega square 2, and ROC is sigma greater than 0. Therefore the ROC therefore the Laplace transform sin omega t is nothing but omega divided by s square plus omega square, where sigma ROC is sigma greater than 0. Same case here. For the Laplace transform cos omega t ut is nothing but s upon s square omega square 2, and sigma is greater than 0. Okay, when we plot the ROC of the signal, okay, for the sine case, as we know that there is two pole but no 0. The two pole at the imaginary axis, s square is equal to minus omega square, and okay, for this s square equal to minus omega square, and the value of s is nothing but plus minus j omega naught to value. Okay, and when we draw it, the one pole here and then one pole here, both at the imaginary axis, as the ROC is greater than sigma equal to 0, and the sigma equal to 0 at this position, sigma is greater than 0. Therefore the ROC of the sin omega t ut is entire right sided of this plane, S plane. Same for the cos omega t ut, as there is one pole and one 0. The pole or two pole and one 0. The pole is also, this is the pole for the denominator. Pole is s value is for plus minus j omega naught, and this 0 at s is equal to 0. Okay, when we plot it, the 0 plot with this circle and two pole plot this, and same the ROC is greater than 0, therefore the ROC is plotted right sided of sigma equal to 0. Okay, now last question for today's discussion. It is to determine the Laplace transform of hyperbolic sinusoidal function. When previously we have discussed the sin omega t, but today we are going to discuss about the sin h omega t. Sin h omega t, h represents the hyperbolic. The only difference is that there is no imaginary term present in this xt, because in the previous discussion we know that the sin omega t represented by e to the power j omega t and minus e to the power j omega t divided by 2j. But in this section this is defined by e to the power omega naught t and minus e to the power minus omega t. There is no imaginary term present in this side, and also divided by 2, there is no imaginary part present in this side. Okay, same for the cost. And when we plot this signal, the Laplace transform from the previous section, the Laplace transform this signal become e to the power 1 upon s minus omega naught. And similar here, this is 1 upon s plus omega naught. As this omega is real term, therefore the ROC of here ROC is nothing but the real term of s is greater than 0. Therefore the ROC of first term is sigma is greater than omega naught, and in this sigma is greater than minus omega naught. When we combine that when we plot in the S plane, and let us plot this. Let's suppose one represent the minus one represent the omega naught. Let's suppose omega naught at this side and minus omega naught at this side. Okay, then first equation tells that the sigma should greater than omega naught this is, and should greater than this type, and second shows that it is greater than minus omega naught at same right side end. As we know that from the property of our ROC, and it tells that the ROC does not contain any pole, therefore the minus omega naught not present, and only the ROC should sigma greater than equal to rightmost plane, which is sigma greater than omega naught. Therefore our common ROC become sigma greater than omega naught. Similar for this case cos term. Now combine this both the signal, and we get omega naught s square minus omega naught square. Similarly omega s upon s square minus omega naught square. And we got this one point there. It has two pole at omega naught and one at minus omega naught. Sorry. The pole is also at it has two pole. Okay, s square equal to omega naught square, and then s is equal to plus minus omega naught. One pole at this side and one pole at this side, and their common ROC become the right side of omega naught. Same for this side. It has also two pole, one at omega minus omega naught and one at omega naught, and one 0 at the 0 as sigma equal to 0, and then ROC is also right sided. Okay, it is enough for today's lecture. Thank you.